Hi everyone, my name is Verena and thank you for joining today's webinar introducing HiveMQ Cloud. With me is HiveMQ CTO and co-founder Dominik Obermaier and HiveMQ Cloud Product Manager Magi Erber, who will be hosting this webinar today. Before we start, I have a few tips for you. You can ask questions during the session by clicking on the Q&A button. And these questions will be answered by Dominik and Magi during the Q&A session after their presentation. If we can't answer all questions due to time issues, we will answer them on our community forum. The link will be shared with you afterwards. We would also be happy if you leave us feedback. So we will start a poll during the Q&A session, and we would be very happy if you leave feedback for us to improve our webinar. And I think that's it for now. So I will hand over to Dominik.
Okay, hi everybody. Thank you for tuning in today. It's a pleasure for us to introduce you our newest product, HiveMQ Cloud. And we will show you why it's important, what we are launching, and we will also give a quick demo and a brief glance at what's coming next and what we have planned for you for the next few months. So again, thank you for tuning in. My name is Dominik Obermaier. I am the CTO and co-founder here at HiveMQ. I'm doing a lot of work with MQTT and Internet of Things. I'm an author, I'm a conference speaker. I am participating in different national and international conferences. And in general, I love building and creating products for our distributed world. And with me is Magi Erber. She's a product manager here at HiveMQ. She's also a conference speaker. She's an author. And she's an expert for cloud native technologies, including Apache Kafka, and is also responsible for our work here because we have some very good integrations with ecosystem technologies like Kafka, but more on this later on. You can also follow me and Magi on Twitter and can also connect via LinkedIn if you want, so it would be a pleasure. And our Twitter handles are here above the picture. As we speak today, millions of things are newly connected to the internet, and thousands and tens of thousands of these internet connected devices get connected each second and each minute. So the Internet of Things is something which is very, very real. This is not something which is a future topic, but it's very, very real. But how real is the Internet of Things and how huge is the Internet of Things? What you see here is a chart which shows the people on the internet. And what you see here is, so the dot can be replaced with a comma if you're in the US. What you see here in this picture is a chart which shows that in 2018, approximately 4 billion people were connected to the internet. And recent studies show that in 2020, almost 5 billion people have access to the internet. While in 2005, we were talking about 1 billion people with access to the public internet. And this is huge. This is a huge thing. But how huge is this? If we compare it with the predicted devices connected to the internet, we will see that in 2025, it's predicted that 75 billion devices are connected to the internet. And in 2018, 2019, we were talking a bit about more than 20 billion devices, and this is rapidly growing. And if you look closely, you will see a small line here above, and this line is the same chart we just saw. These are the people on the internet. So we actually outnumber the devices connected to the internet for a while, and this is rapidly growing and accelerating. So this is a huge thing. So the Internet of Things is really, really huge. But if you think about it, there are specific challenges to solve, especially compared to the classic web technologies we developed in the last 40 to 50 years. And one of them is scalability. So people who are familiar with large enterprise IT infrastructures probably can imagine that it's a very hard problem to connect millions or even billions of IoT devices to these classic infrastructures. So, so I personally have a background with enterprise IT software, and even hundreds of thousands of concurrent users required large applications back then. And if you're talking about the Internet of Things, we are really talking about massive scalability, and companies are currently challenged with connecting these devices and the data the devices produce to their infrastructure systems they already operate, like databases, like application server, like the applications they have. And so this is really a huge technological challenge companies face. And there's another challenge, which we call instant data delivery. And if you think about it, smartphones spoiled end customers forever, especially messaging services like WhatsApp. Due to WhatsApp and other similar services, end customers require and demand instant user experiences. And so people are used to sending messages in perceived real time across the globe and connect with their friends and families. But the same thing also is true for things. If end users interact with physical things, like in a smart home, or let's say if you have a car sharing service, end customers require instant data delivery, require instant user experiences, which requires instant data delivery. And if you combine this with scale, this is a huge problem, because even if you have millions or even billions of users, each of these users requires this instant experience. And it's not enough to have an awesome experience for 90% of the people. You should really be striving for 100% customer satisfaction. And so this is a huge challenge companies face currently. And if you are going to mission critical systems like manufacturing systems, this is even more important. Besides the instant data delivery, which is required, we are also having another challenge, which is reliability. And both in combination is also a very hard problem to solve. Speaking of reliability, although people and customers demand reliability, we live in a world which is not perfect, and we live in a world where especially mobile networks are still unreliable and continue to be unreliable. So internet connectivity, although it's absolutely necessary for our daily lives, is still sometimes very flaky. And so we're a company here in Europe, and especially here in Germany, everybody who drives in a train in Germany can experience the unreliable networks in a very profound manner. So, because basically the internet doesn't work as soon as you drive a train. And so, and in combination, the scalability, the unreliable networks, and customers wanting a reliable and instant experience with devices, IoT devices or apps and services, this is a very, very huge technical challenge. And what makes it even worse is that physical devices are very hard to update, to patch, and it's sometimes very hard to patch your whole device fleet at all. And so it's important to have a reliable channel to the internet for data exchange, which you could probably also use for updating your apps and services on devices with the cloud, even if networks are unreliable. And as a rule of thumb, it's much easier to update any technology on the cloud or in the cloud than if you update any physical devices you probably deliver to your customers and you don't have physical access to. And the huge problem here is the technology we created for the web, like HTTP and a lot of similar technologies, are used for building the Internet of Humans. and sometimes for building Internet of Things. But the technologies we built for humans in the last 40 years is not necessarily a good technology for the Internet of Things. And in fact, you require a completely different technology for connecting stuff over the internet. And that's not all, there are more challenges, like flexibility. And IoT devices and services may change and evolve in the future. If you now ship something physical to your customers, you want to update it and add new functionality. And companies like Tesla really showed that, and also spoiled customers who believe you can update because it's just software, you can update anything. But you need to design, of course, your devices to do this. And also from a business side, time to market is extremely critical. And companies utilize lean or agile principles to ship new features as required and learn how the customer behaves. And the thing here is also, on the cloud side, this is pretty easy, or this is at least a solved problem, and there are technologies which make it very easy. On the device side, this is still pretty hard to roll out new functionality. And a bidirectional communication, which means a device can communicate with the cloud and the cloud can communicate with the device in a secure manner, is absolutely critical for building or for having this flexibility. And also very important, and this is not something special to IoT, but this is something which most technologies we developed in the last 40 to 50 years is how do we protect our investment? And usually the question arises when you're tying yourself to some vendor, and especially if you're doing business critical stuff and you're tying yourself to some vendor, like a database vendor in the past, but now we're talking about cloud vendors. Can you, as a vendor yourself, can you, or are you able to get out of the vendor login? Is your let's say cloud vendor trusted enough that you trust him or you trust it, that even if your business operates for 10 to 15 years with a specific service, that it's still there? And yes, there are many questions here, and investment protection is extremely critical. And this is why in the past, this is basically a solved problem, because in the past, what we created something called standards. We created open standards, which allow us to protect our investment, because we're able to switch our let's say vendors, like our database vendor or a cloud vendor, in case we don't want to do business with them anymore, or they don't do this kind of business with us anymore. So we still have the investment, we still protect our investment, and we don't need to update devices just if let's say my cloud vendor asks me for doing this, because they're changing their APIs, which is in fact something that happened in the past quite frequently. And really the thing here is we need open standards designed for the Internet of Things. And this is where MQTT as an open standard comes in. And this is something MQTT as a technology actually was built for. So for people new to that MQTT technology, let me quickly explain what this is. MQTT is an IoT messaging protocol, and also now it is used very often for industrial Internet of Things use cases, which was created for extreme scale and instant data exchange over the internet, especially over unreliable networks. And this is, by the way, not a new technology. It was built 1999, so this is a mature technology. But now it really got very popular, because now the problems, the IoT problems we face, get mainstream. And in 1999, this was a very niche problem which was solved. But now with the rise of the new technologies we have nowadays, MQTT is now the most popular protocol for connecting things over the internet, because it was built for machines. It is binary, it's data agnostic, and it implements a push technology. And this is super critical, because now this allows instant data exchange across the globe. And the typical use cases for MQTT you usually see are connected cars is like a prime example. Industry 4.0 here in Germany, very, very huge topic. Industrial IoT, also a very huge topic. Logistics, transportation, messaging middleware in general. We see MQTT used as a replacement for this traditional, very heavy, very proprietary messaging middlewares. And also for telcos, MQTT is a very important protocol. And in general, MQTT is used nowadays in case you have a push, you need a push communication, especially over unreliable networks, and you need this reliable communication channel. It was built for constrained devices with very low computing power and very low memory requirements. And in case if you're dealing with low bandwidth and high latency, MQTT is probably the technology you want to use. Historically, what options do we have to deploy MQTT? Let's say if you want to use MQTT in your business critical use case, in your company, what options do you have? And traditionally, there are really two options. You go to a proprietary cloud vendor, which gives you some kind of MQTT. We will see this in a minute. Or you host it yourself, which is for most companies the option they take. If you are going for a self-hosted route, this is the journey is typically most users start with an open source MQTT broker like Mosquito or HiveMQ Community Edition, which is completely free and you can use for everything. And this is super nice for proof of concepts, because most IoT projects we see use a proof of concept first before they roll it out in production. Because again, IoT use cases usually are digitization projects or companies are building new services or products. And very often also they ship physical products to the customers. And so it's important to have this kind of proof of concept cycle before going to production and see if this is really worth the investment. And if you're going to production, a lot of people see, okay, proof of concept are pretty easy to do with MQTT, and production is hard. And this is why we built HiveMQ. HiveMQ as an enterprise MQTT broker makes running a production system self-hosted very, very easy. And this is because this is built for mission critical use cases. But still, companies deploying, especially deploying large clusters and large, let's say, deployments, they face multiple technologies. So there's very often it's hosted in the cloud or in their own data center. Sometimes Kubernetes is in the mix. And also sometimes even kernel tuning, Linux kernel tuning is involved when dealing with millions of open TCP connections, which you require for MQTT from a technical point of view. This is something we as HiveMQ help our customers with, but it's still something, if you're hosting it yourself, you need to deal with it. And also, if you're running 24/7, you usually have some people on staff who make sure the system is running. Also, all the surrounding systems are running, like the applications, the databases, and everything. And also you need to make sure that you also connect all your external services. And it sometimes needs custom programming, sometimes not. HiveMQ allows us with the extensive extension system. But still, you need monitoring and availability is key. HiveMQ makes this easy, but still you need to run it yourself. And if you go the other route and go to a cloud vendor, like you go to AWS IoT or to Azure IoT Hub, and they claim to support MQTT. This is, for POCs, this sounds like a no-brainer because you don't have to deal with anything. The problem here is these cloud services do not support the MQTT ISO standard. And the thing is, which is super critical, that you are using the standardized version of MQTT, because only if you're using the standardized MQTT version, you can switch your implementations on the cloud side. And unfortunately, at least as of today, Azure IoT Hub and AWS IoT do not support the MQTT5 specification, which is out there for almost 2 years. And it also doesn't support all MQTT3 features, which is the previous version. And they only support a subset. And they are very opinionated how you should use it. So you're really locked into the vendor because you cannot easily switch your devices to another cloud without updating them, which very often requires physical access, and very often you cannot even do this. And this is a huge problem. If you need to get access to your shipped physical devices just to switch your cloud vendor. So you're really locked into a specific platform. You're locked into the Microsoft ecosystem or to the AWS ecosystem or to the Google ecosystem, because they also have a similar non-feature complete proprietary MQTT implementation. And you can even look, so the good thing is they're transparent what they can do and what they cannot do. So if you go to Microsoft, you can see the limitations. And the first thing you see is that they do not support the all behaviors specified in the standard, which are, by the way, mandatory behaviors from a specification point of view to be compliant to the standard. And also, if you look at AWS IoT, you see a lot of restrictions. For instance, you don't even get guaranteed message ordering. So your messages can get mixed up anytime. So you cannot rely here. So these are very basic messaging behaviors, and they're not conforming at all with the MQTT specification. So this for some customers, we saw this is a huge problem. Another thing is, which we very often see, is unpredictable pricing. So especially if you're running into production, you really need predictable pricing. And cloud vendors make it sometimes very hard to understand what your production payload will cost. But the good thing is it's pretty easy and pretty cheap to get started with a proof of concept. But as soon as you're logged into the ecosystem and as soon as you go to production, it could be that the bill is not what you expect, unless you're really sure what kind of workload you're using. So this is something we also see from customers who got surprised by the bill at the end of the day when integrating services together. And when it comes to MQTT5 support, which is really nowadays every IoT project which starts new, which we see, uses MQTT5. This is the standard, the most complete and from my point of view, the most important MQTT version ever released. It allows new use cases, especially for industrial IoT, which were not possible with the old version of MQTT3. The ecosystem is there, but as of today, you cannot use MQTT5 with the proprietary cloud vendors. So we live in a multi-cloud world, but still IoT applications do not exist in a multi-cloud world because, it seems like everybody wants to lock you in. And the option we see here is a third option for deployments. It's not only self-hosted, it's not the big cloud vendors. It's what we call a cloud-native IoT messaging service. And let me explain what this is and why this is important. A cloud-native IoT messaging service has 5 characteristics which are extremely important. Number 1, it's based on open standards. Open standards define the internet. Open standards are important for interoperability, and open standards are the foundation for investment protection, especially if you're building new use cases and new products. Second, it needs transparent and elastic scalability. As a customer, you should not care about scalability. It should just work. Third, transparent fault tolerance and high availability. In our always on world, it's important that everything is always on. So even if you only have 99.9% availability, you have multiple hours of customers who get let down. So this is a huge problem. Things just need to work, especially if you are using centralized architectures, which you usually get with deploying things to the cloud. Fourth, a cloud-native IoT messaging service needs to be cloud agnostic. So you should really have the freedom to transmit and store data on any cloud platform you want, and be it your own data center, or be it like the big providers like AWS, GCP, or Azure, or some of the other vendors. Fifth, data integration with other services is extremely important. You need the freedom to choose where to put your data, where to stream your data. And if you want to stream your data today into Kafka, tomorrow into Kinesis, or both at once, you should have the freedom. And so a cloud native IoT messaging service needs this kind of data integration. And this is where we saw that the market needs this, and this is what our customers pushed us towards, is really to see this new category of software, this new cloud native IoT messaging. And what you see here is, when we say open standards, when it comes to IoT, the open standard is MQTT. And all the things connect themselves to this cloud native IoT messaging service. And here let's say in the backend, what we call backend, on the different clouds or even the third parties, you can basically connect anything and stream data to and from any application, be it your own, be it third-party services, on any cloud from any provider. And you should have the absolute freedom of choice where to put your data, where to store your data, and what you do with the data. And you should absolutely be able to even change the cloud native IoT messaging layer. And especially important that you can also change the third-party services you're connecting to, because if you have services runtimes of 10 to 15 years, this will change. And if you ask analysts like Stephen O'Grady, who is a principal analyst at Redmonk, he recently said, as enterprises furiously adopt cloud as part of the overall architecture, one of the choices they are forced to make will be whether to rely on services native to a single cloud vendor. While these can seem more convenient in the short term, they have the unfortunate side effect of locking buyers to a single platform. This is why customers are increasingly placing a high value on neutral, standards-based software layers that allow for seamless operation across different cloud providers. This is, in essence, what HiveMQ Cloud is built for. So even analysts see this demand and the cloud neutrality. Okay, and this is why we built HiveMQ Cloud. This is what it's about. And now we'd like to present you what HiveMQ Cloud actually is, what features we have for you, and how we can get started today. And now I want to give it to Magi.
Yeah, thank you, Dominik. So welcome from my side, and I'm very happy to introduce you to HiveMQ Cloud, our first IoT messaging service. So what is HiveMQ Cloud? HiveMQ Cloud itself is a completely managed MQTT broker service in the cloud with best-in-class third-party integrations. So that means if you create your MQTT broker with HiveMQ Cloud, you do not have to care about the operation of the MQTT broker. So it's really completely managed. And we used here the best practices we learned over the past 7 years. And we also use the same architecture that is used by the major automotive platforms and our largest customer deployments. So it is really made for production. So even if you want to connect hundreds of thousands of clients, there is no problem with HiveMQ Cloud. Because we used automatic scalability and reliability here. Of course, HiveMQ Cloud is cloud agnostic, so it really doesn't matter if you want to connect to any of the big cloud providers here. Sure, we used also enterprise-grade security we always use with cloud, our biggest deployments out there, because enterprise-grade security is really important thing here. And if you use HiveMQ, or if you're used to HiveMQ, you know that we are really 100% compliant to the MQTT specification, and important here to all MQTT specifications, so to the versions 3 and 5. Of course, you have integrated our HiveMQ Control Center, which means that you have the possibility to observe all your IoT devices and have a real-time analytics here. And yeah, integration with best-of-breed third-party services is all, of course, also possible. And what was important to us is also to have a predictable pricing, but more on this later. So what means built for production? First of all, your HiveMQ Cloud MQTT broker is really deployed on a dedicated, highly available infrastructure. So that means you're not sharing any information with other companies like some other cloud services do. And it's ensured that you have a predictable performance, since no disk, compute, network, memory, or something else is shared. And also it is ensured that your data is secure and that your privacy of your data is there, since the infrastructure is not shared. So we also deployed your HiveMQ Cloud MQTT broker across 3 availability zones. That makes it really reliable. So even if the underlying infrastructure is not there for some reason, you have the 2 other HiveMQ brokers that are running in a cluster. So HiveMQ will be always there for you. And to not have a single point of failure, we also added 2 load balancers in front for redundancy. So one load balancer can take over if the other one is not available. I said HiveMQ Cloud is built for production. That means if you want to connect hundreds of thousands of clients, that is absolutely no problem. HiveMQ can handle this. It's also ensured to have a high message throughput of thousands of messages per second. And of course, if you have a HiveMQ Cloud deployment, then you get also a 24/7 professional HiveMQ support. So in case you have any problem or question, we are really there for you. So HiveMQ Cloud is made for production. Because we used a completely automated infrastructure, HiveMQ Cloud automatically scales to the need to the demands you need. And of course, we use our unique clustering technology that HiveMQ customers are used to. So we can also scale here and be really, have the availability you need for a production system. So I said security is important to us, and that is true. So for us, it's important that the communication between clients and the HiveMQ cluster is secured, and we ensure that by TLS secured communication. And also MQTT clients have to authenticate themselves at the broker. And if you know the HiveMQ Control Center, we also have an authentication for the HiveMQ Control Center user there. So only the clients and the Control Center user that you want to connect to your MQTT broker are allowed to connect to. Of course, we are 100% compliant to the MQTT specification, and here really to all MQTT protocol versions. That means MQTT 5 and 3. And important is here that HiveMQ is able to connect MQTT 5 and 3 clients in an interoperable way. So if you have both versions at your clients deployed, then HiveMQ and HiveMQ Cloud are able to handle those clients equally. And that makes it so cool, because you can really use all the MQTT features you want, like all the quality of services, shared subscriptions, user properties, retained messages, persistent sessions. So everything you want from all the MQTT versions. And because we are using the HiveMQ as an MQTT broker, you also have the ability to use the HiveMQ Control Center, which is our admin UI. That means you really have the possibility to monitor your HiveMQ Cloud cluster in real time. So you get a client overview and also a detailed view of all the clients you have currently connected. We have advanced analytics here if a client shows some irregular behavior. And yeah, of course, the health of the cluster we can also monitor here. So, but we will see that later. So as we said, predictable pricing is important to us. So we really want that you know what you have to pay at the end of the month. So what is included in the price is the deployment on a dedicated infrastructure across 3 different data centers. Of course, the 100% MQTT specification compliance and our HiveMQ support for 24/7. And 1 terabyte of data traffic is free per month. That means if your clients connect to HiveMQ and publish data, 1 terabyte of these is free. And if you need more, you can buy additional data. So we have a basic hourly price for $7.50 per hour. And if you need more than 1 terabyte of data, then it will cost you $15 per additional gigabyte. But the 1 terabyte is really per month. So usually this is enough for most of our customers' deployments. So yeah. Okay, so I'd say let's have a look at HiveMQ Cloud. Okay, so it's a cloud service, so we have to log in. And what you see here is the overview of HiveMQ Cloud. And if you're here on Manage Cluster, then you see the overview of all the clusters that were created in your account. So at the moment, we have a lot of deleted clusters and 1 running cluster. And if you want to create a new cluster, then just click here on Create Cluster, accept the pricing. We do not need any credentials at the moment. And the new cluster now is creating. Because we are deploying your cluster on a dedicated infrastructure, this will take some time. And therefore, we already deployed a cluster and can have a look into the HiveMQ Control Center. So HiveMQ customers are used to this view, but I think I'll just walk through it. So what you see here is the overview of your HiveMQ Cloud cluster. You can see here, connected clients and all the publish rates or incoming and outgoing publish rates, and how's the health of the cluster. We also have client overview here. And as you see here, I just created some clients that are now connecting to the cluster. So we wait some minutes for them to be connected. And if we have a look here in the client's overview and create a snapshot, then we also have the overview of all the connected clients here. Let's have a look at one of the clients. Let's take this one. So, and here in the client detail view, you see all the important information for this client. So what's the ID, the username and password, which version, and so on. So really everything you need to know is displayed here. You can also have a look here at the subscriptions, unsubscribe the client. So really administrative actions can be made here from the control center. Okay, then here in the analytics, we can have we see if some client behaves irregularly. So if a client drops messages, so the broker is not delivering the messages to the broker, then it will show up here and you can do some actions to investigate why this happens. And if you have some irregular behavior that you can't explain yourself, we also have here a tool that's called trace recordings. And with the trace recordings, you can create a combination of filters and select messages or specific clients for specific clients or topics, and that are then logged to a file in a human readable format. And then you can walk through the file and see what happened exactly at the broker. So if you have a problem, this is really a cool tool to investigate what's happening here. Okay, let's have a look at the dashboard again. And yeah, you see some clients are connecting, hundreds of thousands, and are publishing and subscribing and receiving messages. So no problem. Okay, coming back to our presentation. So at the moment, we have the one plan I presented to you. That is really a plan that is made for production, but we see that some customers want a smaller plan, for example, for testing purposes, and that is something that will come soon. So smaller plans are on the roadmap. And also, I'm not sure if I mentioned that, but at the moment, HiveMQ Cloud is running on AWS, and we are also supporting all the big cloud providers soon, so like Azure or Google Cloud, that will come soon. And also the support for multiple regions will come soon. We said that the integrations with third-party services is pretty important to any IoT deployment, and that is true, and that will also come soon. So we will have external authentication providers like Okta or ForgeRock, the possibility to send your data to a Kafka cluster like Confluent Cloud, or also integrate other services like device management. And so our motto here is really connect once and integrate everywhere. And then some features that will come soon. So VPC peering. So I think that is something that is really important to a lot of our customers. Also the support for custom URLs and the support for custom and pre-built extensions. Okay.
Okay, so now we still have some time left for questions. And also, as Verena said in the beginning of the webinar, we would be very grateful if you would use the feedback form you should see right now. So you can rate the webinar and tell us what you think, tell us what we can do better. And in the meantime, we are happy to answer any questions you have. And so please don't be shy. So you can still pose questions, and we're going to answer them right now. Okay, so let's start with the first question. So we had a question regarding, are you considering a free tier plan to allow for a proof of concept development? Yes, this is on our roadmap. For now, we deploy dedicated infrastructure. So we also, for interested companies, we also offer to talk to your sales team for now, and we will make sure you get your free infrastructure for your proof of concepts. So for now, this requires, let's say, a quick interaction with us, but we are having this on our roadmap, so you can, in the future, you will have this free infrastructure right into your account, and you can try everything your own. Okay, then we have a question. So the question is, are there limits for using HiveMQ Cloud? And are there any limits in terms of connection and messages transmitted? So in general, there aren't any restrictions. So because this is infrastructure dedicated for you, if you deploy the plan which I showed you, which is our production plan, then you don't have any message transmission limits. It really depends on your workload, but usually we talk about tens of thousands of messages per second you can send and receive. And we also offer for customers with more ambitious deployments, we also offer bigger plans. So this is absolutely possible. And when it comes to limit of connections, so it's currently limited to 250,000 device connections if you do the plan, but this is not a technical limitation here. So you just reach out to us, and also as soon as we see you hit the limit, we will of course increase it for you. This is just for your protection in the beginning, that you don't accidentally, especially when you're having integrations, running into problems. But in general, we strive to have the infrastructure available for you require for your production use case. So we got a question where the servers are located. For now, it's in Frankfurt in Europe and Germany. This is a data center which has one of the highest, let's say, restrictions when it comes to GDPR, when it comes to any regulations. One of the, let's say, strictest requirements here in the world. But of course, since MQTT deployments usually should be located near where your devices are deployed, we will offer, as Magi told, we will offer very soon for you the ability to decide where your cluster is deployed, in which kind of data center, and of course also in which cloud. So this is something very soon. For now, it's in Frankfurt. Also, if you're using the product right now, you can give us a call, write us an email, and we will make sure that it runs on the data center you require. Okay, then we have a question about smaller plans. So yes, we will have smaller plans. And also, if you are doing proof of concepts, if you are requiring some help, reach out to us. We will help you set it up so it works for you. If this, let's say, if you're not yet in a stage where you want to run in production, for now we of course help here, and very soon we will have this available as a self-service on our portal. Okay. Okay, so there's a question, what is the real benefit to communicate through HiveMQ? I pay HiveMQ or Azure AWS for MQTT, it will be the same at the end, as long as I have no multi-cloud strategy existing. It really depends. So if for your use cases, it's absolutely okay to have not MQTT, but a proprietary version you get at AWS or Azure. And if it's not mission critical and you do not need the freedom of choice, and also if you can update your devices, and so you're not required, so it's not a problem for you if any pricing change occurs, or if the APIs don't exist for multiple years, because you at both providers you get 1 year of notice to update your applications. And then if this is possible for you, then there isn't really any benefit. If you are looking for standard-based communication, if you want to use the new MQTT5 features, which most use cases today require, then we would suggest that you take a look at HiveMQ Cloud. In case it's still unclear for you if your use case requires this, or if a proprietary communication is good enough for you, we can do this in a one-on-one conversation. So, but there are use cases where completely proprietary communication is possible and is okay. And this use case, probably HiveMQ Cloud is not an option for you. But for most companies who are building businesses upon IoT use cases, it's really something I recommend, that we don't need to relearn what we've learned in the last 40 to 50 years in computing, that open standards are important. And in fact, you can use HiveMQ for the open standards. And at a later point of time, if you don't like HiveMQ at all, you can still switch to any other vendor if the vendor supports 100% MQTT. Okay, some other questions. So there's a question, HiveMQ is cloud agnostic. It is not completely clear for me. Is HiveMQ Cloud the service that will be deployed to my existing AWS Azure Google account, or shouldn't I care about the infrastructure at all? So we here at HiveMQ believe that you shouldn't care at all about infrastructure. So we manage this for you. So you do not need a team who is running a service 24/7. You do not need to give us any kind of credentials you have. We will deploy this for you, we will run it for you, and we will make sure that your data is secure. And also, what we will do very soon, you can also do VPC peering soon, which means if you are running your own cloud with your applications and do not want to use MQTT over the internet, but with a local deployment, or let's say you want to, let's say, connect the clouds together. This is possible because we give you dedicated infrastructure. We can build this bridge. In AWS, it's called VPC peering, but of course, we will also offer this for the other cloud services. So there's another question. So let's consider the following scenario. Client X is connected to HiveMQ Cloud and gets some messages. Then the device lost the connection and reconnects after 5 minutes. In the meantime, there are a couple of messages sent to the client. Will it receive all of them? Yes, of course. So this is something the MQTT protocol requires to do. And this is also a limitation. Some big clouds do have limitations to this behavior, but we find this is extremely important because the reality is we do have unreliable networks all the time. So it should be, so MQTT makes it super easy for the programmer to receive and send messages, and HiveMQ will take care. There is, of course, a limit. So especially, which is usually we see this if a device is not turned on for like a few months or so, then the device won't be interested in all the messages. But MQTT 5 here has this nice feature of message exploration. HiveMQ, of course, supports. And so basically, yes, we will receive all the messages, but there is a message queue limit, which is 1,000 messages per device, which can be changed by you. If you know you have devices who need a huger limit, but usually this is there to protect devices. We have seen multiple cases where a device got online after a few months and then it was basically overwhelmed by tens of thousands of messages. So it is important to restrict this, and HiveMQ restricts this for you, but of course you can change this. But this is really something I recommend that you think about the use case if it makes sense for all your devices. Okay. Any plans for US-based AWS? Yes, we do have this. So this will be shipped very soon. So you will be able to run the HiveMQ cluster on US data centers, in US data centers. So you get the full experience of the completely hassle-free HiveMQ Cloud, and you also get the lowest latencies available as if you're based in the US. So this will be possible, yes. So do you have any comparison charts between HiveMQ Cloud and other MQTT cloud vendors? Yes, of course we do. We know the market very well. If you're interested in learning about the differences, I would recommend to reach out to me or to me directly or to my team, so we can make sure that to help you understand the limitations from other vendors. So HiveMQ is really the 100% MQTT experience. And but of course, if you are deciding or you don't need all the features or reliability is not important for you, you of course have the comparison. So also for other vendors. So please reach out for that. Okay, so I think we have time for one question. So your one slide positioned backend services like AWS, IoT, Confluent, Kafka, etc. If the HiveMQ Cloud is between us and the backend, who is responsible for the integration and supporting the communication channels between the two? Are the license extension, or do we have to configure the backend and work through HiveMQ to activate? So this is a very good question. This is really about the flexibility I talked about and the freedom of choice we believe our customers should have, and basically everybody should have in today's cloud native world. So HiveMQ is extremely extensible. So you can have your own extensions if you have your own backends with a proprietary protocol. But of course, we have a lot of these extensions we have for our on-premise offering right now. We will ship them to HiveMQ Cloud. So let's say for Confluent Cloud, you can just, let's say, connect Confluent Cloud and HiveMQ together very easy in a hassle-free way. And you have the freedom of choice. Of course, you can also, if your service or your, let's say, backend service supports MQTT currently, you can just plug this together by consuming messages via MQTT, or HiveMQ is really able to speak virtually any proprietary protocol to the backend. So we have a lot of extensions coming here in the next month, so stay tuned. And you, of course, also can bring your own extensions. And this is something we're also shipping very soon, so you can program it yourself if you want, if you have some exotic use case or some custom backend which is not supported by us. This will be shipped very soon. Okay, so I think we're out of time. So for all the other questions, we will make sure to get them answered on our community forum as always.
Yes. So yeah, I think that's it. Like Dominik already mentioned, all unanswered questions will be answered on the HiveMQ community forum. We will share this link with you in an email. We will also upload this webinar on our YouTube channel. If you want to stay updated on our upcoming webinars or on our blog post, you can subscribe to our newsletter, and you can also already subscribe and register for the next webinar in March, which will be on machine-to-machine communication with Azure IoT Edge and HiveMQ, and we will also share this link with you. So thank you very much, Magi and Dominik, for introducing HiveMQ Cloud to us. We hope you liked it, and we hope to see you again in March. So thanks for attending and take care. Goodbye.
Yeah, thanks, everybody.
Thank you.